Hi there, Joshua here. So here's a very nice mathematical recipe for you. So what you want to do is you want to take about 3.14 kilograms of pastry, pour in about 3.14 litres of mixed vegetables, carrots, peas, etc. You want to add about 3.14 grams of butter, maybe about 3.14 millilitres of milk. Put it in the oven, wait for about 3.14 minutes, open the door, vegetable pie. Let's get on with the lesson. Right, so welcome to this lesson on vectors. First of all, I'm going to explain what vectors are. So I like to think of a vector as a movement or a journey. To help explain this, I've got a grid with 4 points, A, B, C and D, and I'm going to talk about the journey from one point to another. So the vector A to B, is just the journey from point A to point B. And we use an arrow to show which way we're going when we're talking about vectors. So the vector A to B is basically it's just this journey, the journey from point A to point B. Now how can we describe that using numbers? Well, when you go from A to B, you go across 3 squares and up 2 squares. So one way to write it is to say that it's 3, 2. We write the across number first and the up or down number underneath. That's called a column vector, and 3, 2 just means right 3, up 2. What about the vector or journey B to C? So how could we write this vector using numbers as a column vector? Well, the journey is right 1, down 4. So the across number first, so it's right 1, and then down 4, we use a negative number for that. We write that as minus 4. So left or down is negative, right or up is positive. So that's vector B to C. This is the column vector, it's just 1 minus 4. What about C to D? So that's that journey. What's the column vector for that? Well, that's just left 1, down 2. So we write that as minus 1, that's left 1, and then down 2 is minus 2. So across number first, up or down number underneath. That's C to D. And what about going back to A? So D to A. What would that journey be? Well, that's left 3, up 4, so that's just minus 3, 4. I'll also do D to B. That's an interesting one. D to B, because that's just straight up. So that's just up 6. So it's across 0, if you like. Up 6. So that's just 0, 6, 0, 6. Now, we did A to B. What about B to A? What about going the other way, the return journey, if you like? So vector B to A, what's that as a column vector? Well, it's left 3, down 2. So left 3 is minus 3, down 2 is minus 2. So notice how they compare. A to B was right 3, up 2, and B to A is left 3, down 2. So it's the same numbers, just different signs. Let's look at the return journeys of all of these vectors. So let's do C to B. C to B. So that'll be left 1, up 4. Left 1 is minus 1, up 4 is just 4. So again, it's the same numbers as B to C, but because it's the return journey, it's just different signs. So I predict that'll be the same for all of these. So let's do the return journey for the rest of them. So D to C, it should be just plus 1, plus 2. So just 1, 2. And you can check that on the grid. That's D to C. Let's do A to D. Well, D to A was minus 3, 4. So A to D is going to be 3 minus 4. And finally, D to B was 0, 6. So B to D is just going to be 0 minus 6. So that's a little bit on vectors going from one point to another point. Now, you don't have to mention points at all when talking about vectors. You can just talk about the vectors themselves. Remember, a vector is just a movement or a journey. So let's draw a couple of movements or journeys on the board. So I'm going to do a little movement over here. Let's call that little a. And let's say a is 4 right, 2 up. Let's say a is that movement. How would we write that as a column vector? Well, that's just 4, 2. 4, 2, 4 right, 2 up. And I'll draw another little movement over here. I'll call that little b. We underline letters to show we're talking about vectors and not numbers. So I'm underlining these letters. That's just vector notation. Let's say little b is sort of left 1 up 3. So left 1 up 3. So how would I write that as a column vector? Well, that's just minus 1, 3. So minus 1, 3, left 1 up 3. So I've got two sort of vectors or movements there. Now you can combine them in different ways to make up other vectors. So for example, you could ask, well, let's say I start somewhere on the page and I do movement A, and then I do movement A again. So I do A and then A again. What's the overall sort of movement from start to finish? We call that journey 2A. That should be a straight line, by the way. So we call that journey 2A. And what's that as a column vector? Well, how far across did I go overall? Well, I went 4 across when I did the first A, and then another 4 to the right when I did the second A. So that's 8 to the right overall. And how far up did I go? Well, I went 2 up the first time, and then 2 up the second time, so that's 4 up overall. So 2A is just 8, 4. And you can probably see to work out 2A, which is 2 lots of 4, 2, you just double both numbers. So it's 8, 4. 3B, which means doing B 3 times, so it's 3 lots of minus 1, 3. To work that out, you just triple the numbers, so it will just be minus 3, 9. Minus 3, 9. So here's B, B is that. 3B would just be 3 of them, so it's just 3 times the journey. So that's 3B. And that's minus 3, 9. You could even do fractions of vectors. So for example, you could do half A. So A is this journey, that's A. So half A would just be half that journey. So that's half A. So what's that going to be? Well, you're going to go half as far across and half as far up. So you could just halve these numbers. So it's just going to be 2, 1. So half A is 2, 1. Right, so now I'm going to talk about adding vectors. So I'm going to pick a sort of a random point on the board, and I'm going to draw out vector A, like that. And then immediately afterwards I'm going to draw out vector B from where I left off, like that. So I did A and then B straight afterwards, and I ended up there. Now it's a natural question to ask, what's the overall journey from start to finish? So what's the overall journey from start to finish if you do A and then you do B immediately afterwards? We call this new vector, this new journey, A plus B. So that's the overall journey from start to finish of doing A and then B. We call it A plus B. And we can work it out as a column vector, just using the picture. A is 4, 2, and B is minus 1, 3. So let's work out A plus B. So how far have we gone overall horizontally? Well, when we did A, we went 4 right, and then we did B and went 1 left. So that's a net movement of 3 to the right. So it's 3 to the right overall. And vertically we went 2 up, and then we went 3 up, so that's 5 up overall. So the overall journey from start to finish is 3, 5. That's 3 right, 5 up overall. And as you can see, to add vectors, you just add the horizontal components and you add the vertical components. So if you were doing this without a picture, and you wanted to know what A plus B was, the overall journey, A is 4, 2, B is minus 1, 3. So you just add these numbers, and then you'd add these numbers, and you'd get 3, 5 overall. Right, let's do B plus A. Let's do B plus A. Is that the same overall journey? Well, let's just draw a picture for it. So B plus A is the overall journey of doing B and then A. So a different order this time. So I'll start here, and I'll just do B, like that, and then A. And then B plus A is the overall journey from start to finish. So this is B plus A. So is that the same as A plus B? Well, let's just work it out. So B is minus 1, 3. A is 4, 2. So how far horizontally have we gone overall? Well, we went 1 left and then 4 right. So that's an overall movement of 3 to the right. So minus 1 plus 4 is 3. And then we went 3 up and 2 up, so that's 5 up overall. So yes, it's exactly the same journey as you'd expect. And to show it's the same journey as a picture, I could just draw B plus A up here, just starting from this point. If you do B, and then you do A, you can see the overall journey, B plus A is this arrow here, which is the same as A plus B. So this is also B plus A, they're the same. Because you've got a parallelogram, so it's the same overall journey. Right, let's just do one more. Let's do 3A plus 2B. And again, I'll draw that out as a picture. So 3A is something like that. Perhaps that's 3A, so starting here. And then immediately afterwards I'll do 2B. So maybe like that. That's 2B. And I've ended there. So the vector 3A plus 2B is just the overall journey from start to finish. So just this journey here. And that's something we can work out, again, as a column vector. 3A is just 3 lots of A, so 3 lots of 4, 2, which is 12, 6. 2B is 2 lots of B, 2 lots of minus 1, 3, which is minus 2, 6. So we have 3A plus 2B. 3A is 12, 6. 2B is minus 2, 6. So let's consider the overall journey now. So horizontally, well, when we did 3A, we went 12 to the right. When we did 2B, we went 2 to the left. So that's an overall movement of 10 to the right. So 12 plus minus 2 is 10. And then vertically, when we did 3A, we went 6 up. When we did 2B, we went 6 up again. So that's a net movement of 12 up overall. 6 plus 6 is 12. So the journey 3A plus 2B is 10 right, 12 up overall. So that's a bit on adding vectors. Right, so now I'm going to talk about minus A and minus B. So we've got A there. I'll just draw it out again. This is vector A, so 4 right, 2 up. Vector minus A is just this vector here. It's just the reverse journey. And if you remember from the first part of the lesson, to get the reverse journey, you just change the signs of the column vector. So minus A is going to be minus 4, minus 2. So it's 4 left, 2 down. We can do the same with B. This is vector B. Left 1 up 3, minus 1, 3. Vector minus B is just the reverse journey. And again, to get it as a column vector, you just change the signs of the numbers. So it's going to be 1 minus 3. That's 1 right, 3 down. Now you can do things also with these vectors like this. Let's say I'll start here on the page. Let's do vector A. And then immediately afterwards, I'm going to do vector B. So I'm going to do vector minus B. So this is minus B. And you might want to know the overall journey of these vectors. So what is the overall journey from start to finish of doing A and then doing minus B? Well, we call this new vector A minus B. And again, we can work that out quite easily. A is 4, 2. Minus B is 1 minus 3. It's 1 right, 3 down. It's the reverse journey of B. So A minus B is just the overall journey. So we went 4 right and then 1 right. So that's a net movement of 5 right overall. And then we went vertically, we went 2 up but 3 down. So overall that's 1 down overall. So A minus B, which is really just the overall journey of A and minus B, is 5 right, 1 down overall. So to work it out, again, you just add these numbers up. So you just do 4 plus 1 and 2 plus minus 3. So to work out A minus B, what you're really working out is you're doing A plus minus B. You're just taking vector A and you're taking vector minus B, like that, and you're just adding the components. So 4 plus minus 1 is 5, 2 plus minus 3 is minus 1. And that's A minus B. Right, let's do one more. Let's do 2B minus 3A. So this is the overall journey of doing 2B and then doing minus 3A. I'll just draw that as a picture. So I'll start, let's say here. This is 2B, something like that. 2B. And then 3A would be that way. So minus 3A would be something like that. That's minus 3A. And 2B minus 3A is the overall journey from start to finish. So let's draw that. This is 2b minus 3a. So let's work that out. Well, 2b is just two lots of b, so two lots of minus 1, 3 is minus 2, 6. And let's work out minus 3a. Well, 3a would just be three lots of that, which is just 12, 6. So minus 3a is just the sort of like the negative of that, which is minus 12 minus 6. So minus 12 minus 6. So that's 12 left, 6 down. So we've got to add those two vectors together to work out 2b minus 3a, to work out the overall journey. So let's just do that. So minus 2 plus minus 12 is minus 14. So we went 2 left and then 12 left, so that's 14 left overall. And then 6 plus minus 6 is 0. So we went 6 up and then 6 down, so that's 0 up or down overall. So the overall journey of doing 2b and then minus 3a is 14 left, 0 up or down. Right, so I'm now going to go through a couple of vector questions. So I'm just going to draw some lines and points on the board. So I'll call this point A, I'll call this point B, I'll call this point C. And suppose I told you that the journey from A to B, the vector A to B, is, let's say, I don't know, 3 right, 6 up, 3, 6. And let's suppose the vector from B to C is 4 right, 2 down. So that'll be 4 minus 2, 4 right, 2 down. And the question is, what is the journey from A to C? So what is vector A to C? Well, to get from A to C, you can go via B, sort of using known vectors, using these vectors. You can just do that and then that. So if we add the vectors along the way, if we just do that plus that, we'll get the overall journey A to C. So to get A to C, you can just do A to B plus B to C, because when you add vectors, that gives you the overall journey. So A to B we've got is 3, 6. B to C is 4 minus 2. And adding them gives you, on the top you've got 3 plus 4, which is 7. And 6 plus minus 2 is 4. So that tells us that the journey from A to C overall is 7 right, 4 up. It's 7, 4. I'll do a similar question over here with 4 points. So I'll just do something like that, let's say. 4 points, I'll call them P, Q, R and S. And let's say P to Q is, let's say that's, I don't know, 2 right, 4 up. So 2, 4. Let's say Q to R is 5 right, 1 up. So let's say Q to R is 5 right, 1 up. And let's say R to S is, let's say 3 right, 2 down. So 3 minus 2. And the question is this time, what is S to P? So going the other way, what is S to P? Now there are a couple of ways of doing this. One way is just to start at S and go to P and add up vectors along the way. We know all these vectors, and then when you add them up, you'll get the overall journey. So to work out S to P, you could just do S to R plus R to Q plus Q to P. And we can work all of those out. So R to S is 3 minus 2. S to R is the reverse journey, so it's going to be the same numbers, just different signs. So it's going to be minus 3, 2. R to Q is just going to be the same as Q to R, just different signs. So it'll be minus 5, minus 1. And Q to P will just be up minus 2, minus 4. And adding them up gives you minus 3 plus minus 5 plus minus 2 is minus 10, is the horizontal number. And 2 plus minus 1 plus minus 4 is minus 3. So that tells us the overall journey from S to P is minus 10, minus 3. 10 left, 3 down overall. The other way I guess you could do this question is you could work out P to S first, and then S to get S to P, just change the signs. For my next question, I'll just do one more down here. I'll just mark 3 points. Call this O, call this A, call this B. And I'll call this journey, this vector, I'll call it little a, the journey from O to A. And I'll call the journey from O to B, I'll call that little b. I'll tell you what those journeys are. So little a, let's say it's 4 left and 6 up. so minus 4, 6. And little b, let's say it's, I don't know, let's say 3 left. So let's say 2 right and 3 up. So 2, 3. 2 right, 3 up. And the question is, what is the journey A to B? So what is A to B? Well, to get from A to B, using the vectors we've been given, you could just do that plus that. Remember, when you add vectors, you're working out the overall journey. So we can just do that plus that. So I'll just write that here. So A to B is that, which is minus A. It's not A, it's minus A, because it's going in the other direction. So it's minus A plus that, which is B. So that's, so minus A is, it's just that with the signs changed. So it's 4 minus 6 plus B, which we have is 2, 3. So what's that overall? 4 plus 2 is 6 on the top. And minus 6 plus 3 is minus 3 underneath. So the overall journey, or vector, A to B, is 6 right, 3 down. Right, so let's do something a bit different to finish off. I've got a triangle drawn on the board. I've marked some points on the triangle. A is meant to be in the middle of this line. So in other words, OA is half of OC. Just make a note of that. So OA is half of OC. And also OB is a quarter of OD. So B is meant to be a quarter of the way along this line. So OB is a quarter of OD. It's just a sketch. And I'm going to call the journey from O to A, I'm going to call that vector little a. So this is little a. And I'm going to call the journey from O to B little b. And it doesn't actually matter what A and B are exactly for this question. A might be 2 right, 5 up or something like that. B might be 4 right, 0 up. It's irrelevant for this question. And what we're going to do is we're going to sort of go from point to point, describing the vectors just using little a and little b. You see this sort of question in textbooks all the time. They'll give you a shape and they'll ask you to go from point to point just using vectors that they give you. The reason they give you these sorts of questions is because if you do geometry at a more advanced level, you can prove a lot of theorems very easily using vectors. But to do that, you need to be good at describing the journey from one point to another point. So by giving you loads of questions like that, they're training you to get better at that sort of thing. So let's try it. Let's try and go from point to point and describe the vectors. So first of all, let's do O to C. Can we describe that journey just using little a or little b? Well, the journey from O to C is double the journey from O to A and in the same direction. So if O to A is little a, then O to C must be 2a. What about O to D? Can we describe that journey in terms of little a or little b? Well, it's kind of similar. The journey from O to D is 4 times the journey from O to B and in the same direction. So it's 4b. What about A to C? What's that in terms of little a or little b? Well, the journey from A to C is exactly the same as the journey from O to A, because point A is in the middle of this line. So it's the same journey and in the same direction. So if that's little a, then that's little a as well. What about B to O? Well, O to B is little b, B to O is the reverse journey, the opposite journey, so it's minus b. What about C to O? What's that in terms of little a or little b? Well, we've done O to C already. O to C was 2a, so C to O, just the opposite direction, it's minus 2a. What about A to B? What's that in terms of little a and little b? Well, to go from A to B, you can go via point O. You could do that and then that. If you add up those vectors, then you'd be working out the overall journey. So A to B is just that plus that. So it's just minus A, because we're going that way, plus B. So it's minus A plus B. And you can write that the other way. You could write that as B and then minus A. It doesn't matter which order you do those two things in. The overall journey is the same. You could do minus A and then B, or you could do B and then minus A, and the overall journey would be the same. It would be the journey from A to B. So you can write it either way round. What about B to C? Let's do that. Can we write that in terms of little a and little b? Well, again, you can go via point O. You could just do that and then that. So the journey B to C is just that vector plus that vector. So it's minus B plus 2A. Minus B plus 2A. Or written the other way round, it would be 2A minus B. What about C to D? C to D. Well, we could go via point O again. It's just that plus that. That is minus 2A, and that is 4B. So it's just minus 2A plus 4B. Or written the other way around, it's just 4B and then minus 2A. So 4B minus 2A. Either way round. Right, now I'm going to introduce a new point. I'm going to call this point M. And M is meant to be the midpoint, the middle of this line. So M is the midpoint, midpoint of CD. Midpoint of line CD, point M. Right, let's go from different points to point M now. This is going to be a bit more difficult. So let's do C to M. What's that in terms of little a and little b? Well, we know what C to D is. C to D is just 4B minus 2A. C to M is just half that journey. So it's just half the journey C to D. So it's just half of 4B minus 2A. Half of 4B minus 2A. And you can actually expand the brackets just like it was normal algebra. So it's just 2B minus A. Remember, you can think of vectors as just pairs of numbers, just a horizontal number and a vertical number. So a lot of the rules that work for numbers in algebra also work for vectors as well, like expanding brackets and factorising and things like that. So that's C to M. What about, let's do a few more, let's do O to M. So O to M. Well, to get from O to M, you can just go via C. So you could go the other way around, but I'm just going to go that way around. So you can just do O to C plus C to M. Remember, adding vectors gives you the overall journey, basically. So O to C, we know, is 2A. C to M is 2B minus A. And then, if you simplify that, 2A minus 1A is just A. And then you've got 2B. Let's just check if that seems right. Does that seem right going from O to M? You do that. So if you did A and then 2B, yeah, that seems about right. Looks like you get to M if you did that. Let's do a couple more. Let's do D to M. D to M. So D to M is the opposite journey of C to M. It's sort of like the reverse journey. So it's just going to be minus C to M. So C to M was just 2B minus A, so it's just going to be the negative of that, minus 2B minus A, like that. And again, you can expand brackets just like it was normal sort of algebra. So it's minus 2B plus A, which you can write the other way around. You can write it as A minus 2B. Let's just do one more. Let's just do B to M to finish off. Just do B to M. So you could go that way around, but I'm going to go the simpler way around. I'm just going to go via D. So I'm just going to do B to D plus D to M, like that. And we know both those things. B to D is just 3B. So it's 3B. And D to M is A minus 2B. So it's A minus 2B. So let's see what we get overall. So overall we get 1A plus 1B. It's just A plus B. Let's just check if that seems right. So starting at B, if we do A and then B, will we get to M? So if we do A and then B, yeah, that seems about right. So that's it.